Question number 2. First thing we have to ascertain is that this is a pyramid. The pyramid is turning upside down. We need to draw in where the centre, apex of that pyramid might sit. So with a degree of accuracy, we need to line up corner to corner to find that the centre here sits in that position. This is slightly off in this particular drawing. From what we can see from this one, it has been cut in these two positions. I'm going to call this A, B, C and D. So in this view here, the nearest to me is B, behind that is A, one nearest to me is C, and behind that is D. I'm going to put X for the apex in each case. We've simply got to start by completing the plan. Let's look to see where the ridge is cut. This ridge is cut in this position, so pencil on, slide the set square across, project up. 2 points of contact. B and A are also cut in this position, so B and A are cut as so. We can then join up. In this case, there is a slope between the two. They do not line up, so we have to make sure we use instruments to find that slope. These cuts are vertical, so we can use the parallel motion and the set square to find the corresponding edges. Drawing's not finished. These lines still need to appear up here. So we now need to firm in internal corners of this cut, hollow, rectangular pyramid. It's cut. This has been removed. It's hollow to allow the light to come out. It's a rectangle and to come down towards a point, so it's a pyramid. For the next part, I'm going to take the centre, project across. We already have a centre line on page ready for us for the end elevation. And in this case, I'm going to use a 45-degree bending line to project the distances front to back, across and down. The heights I can project from the elevation. So first of all, nearest to me is going to be A behind D. Nearest B behind is C. So I can take these 2 points, project them across to my 45-degree bending line. I'm now going to take that point and project it down to the correct level. So nearest me is B, behind that is C, and in this case, nearest to me is A, and behind that is D. These points go down to the apex. If this was complete, that's what we'd see, but this has been removed. So let's look at the places we have the nearest cut. B and A are cut from B to A, so across from B to A. Our next cut is on ridges C and D. I can project that across between C and D. All that remains now is to firm that end elevation in. Remembering that this has been removed. Also important to put the base, or in this case the top, in place. The next one asks us the development of the sides of the lamp. Now the developments of this side are sloping not just sideways but back. So we're going to have to find the true length on these ridges. At the moment this one is sloping both sideways and out. We need to have it flat. To do that we're going to use a technique taught in class, which is to take a corner and rotate it round to the centre plane. That's through the origin. There is a centre plane. That's the base point projected to the centre plane. We're now going to project that to the base, and in this case the base of the pyramid is here. Apex, base. This should give us a true length line. We need the true length line to draw the development. So we put from the apex to the end of the true length line, starting given point we're also given a little hint that we might fit one in as a starting point here. We now have to get the distances between each of the faces. This is rectangular, so I'm going to start at B. I'm going to move around in that direction. From B to C, from B to C. Then changing from C to D to D. From D to A should be the same as B to C, so this is to A now. And I have to close it back over, so from A to B. B. We can now draw in the ridges, the true lengths of those ridges from apex, marked O in the exam question, start on the apex, lining up on the point at the far end, drawing the line. Now this gives a curved base. This does not have a curved base. We can draw in the base straight edge for each of the pyramid points. Remember, this pyramid is upside down, so I'm talking about bases of the pyramid. The pyramid's base is up at the top. That would be the surface development of the complete pyramid, but it's not a complete pyramid. We now have to find where these cuts are. The cuts are not true in this view. The cut has to be projected onto the true length line, and we have 2 points at which the true length are cut. So taking the compasses, and we're starting from the apex to B, I can put on the apex to where it cuts B on the true length line. Not B in the object, B on the true length line. B can now be marked on. B is also around the other side as it closes up, but it's not just B that's cut there, it's also A. So I can mark on A as well. The next part that's cut, C and D. Compasses on the apex, bringing down on the true length line, so we can measure from the apex again, true length line, marks on that ridge. The resulting shape And this is where some simple, avoidable mistakes happen. Which bit am I left with? The point or the base? In this case, it's the base area. This is the part I'm left with. So when I firm in, I need to firm in accurately, carefully, on top of my construction lines. To complete this drawing, we still have some lines to go in. We're asked for the development of the sides of the lamp, not the base, nothing internal, so it's just this part. However, we also have to do in a development is to add where the bends are going to go. And in this case, the bends or folds appear as a fold line, double dash, long line. Fold line. Long, double dash, complete. Last one. Plan, end elevation, surface development, true length line.